Hello, welcome back to the class. So in this class we are going to discuss about the other aspects of chemical equilibrium, that is Lewis acids and bases. According to Lewis, acid is a substance which accepts electron pair and the base is a substance which donates the electron pair. So here Lewis described the acid and the base concept completely on the electron. So when some substances which accepts the electron and becomes acid, and the substances with donates the electron will act as a base. Electron deficient species like AlCl3, BH3, H plus, etc. are act as a acid because it will accept the electron. And some species like H2O, NH3, these are all electron rich species, they will act as a bases. So this is the Lewis concepts of acids and bases. Next one is ionization of acids and bases. Strength of acid or base is determined with the help of extent of ionization in aqueous solution. pH scale, hydrogen ion concentration are measured as the number of gram ions of hydrogen ions present per liter of solution. Since these concentrations are usually small, the concentration is generally expressed as the pH of the solution. pH being the logarithm of reciprocal of hydrogen ion concentration. So that is pH is equals to minus log H plus in terms of mole per liter. It is a logarithm of reciprocal of the hydrogen ion concentration. Actually it is log 1 by H plus concentration. So we can write it as minus log H plus. pH of pure water at 25 degrees Celsius is given as pH minus log, the pure water pH is 10 raised to minus 7. So that is 7 because log of x to the power n is taken as n itself. So it is minus log x to the power minus n form, that is minus n into minus, that is converted into n. So the value becomes 7. Acidic solution has a pH less than 7 and basic solution have a pH greater than 7. For neutral solution pH is equals to 7. If you consider water, the Kw value is equals to 10 raised to minus 14. pKw is equals to pH plus POH. H from this H3O plus, POH from this OH minus, the total value is 14. Next one is di and polybasic acids. Acids which contain more than one ionizable proton per molecules are called as a dibasic acids or a polybasic acid. If it is 2, then it is dibasic. More than 2, then it becomes polybasic acids. Common examples are oxalic acid, sulfuric acid, phosphoric acid. The ionization reaction for a dibasic acid can be represented as H2X. So it will give H plus HX minus, or HX minus will give H plus X2 minus, like that. The equilibrium constant can be written as, applying the law of mass action for this equation as well as for this one. So here Ka1 is equals to product of concentration of the product side H plus Hx minus divided by concentration of the reactant H2x. For this second one equation, Ka2 concentration of H plus into X2 minus divided by concentration of Hx minus. Ka1 and Ka2 are called first and second ionization constant of this acid. Here A stands for acid, 1 and 2 are for first and second reaction. So here Ka1 is greater than Ka2 for dibasic acids. Next one, factors affecting the acid strength. When the strength of HA bond decreases, so in that case the acid strength also varies. Here HF is less acidic than HCl, then HBr and HI. The size increases from this side and the acidic strength will increases from this side. The energy required to break the bond decreases. Ha becomes stronger acid. As the size of the A increases down the group, Ha bond strength decreases so that the acid becomes more acidic, or the compound becomes will increases its acidic strength. In a period, as the electronegativity of A increases, the strength of the acid increases. Here is the sequence. CH3 is less acidic than NH3, then H2O, and HF is more acidic in nature. Next one, common ion effect. If in an aqueous solution of a weak electrolyte, a strong electrolyte is added having an ion common with the weak electrolyte, then the dissociation of the weak electrolyte is decreased or suppressed. The effect by which the dissociation of weak electrolyte is suppressed is known as common ion effect. For example, in an aqueous solution CH3COOH, a small amount of CH3CONA has been added. CH3COH ಇರುತ್ತದೆ, ಅದಕ್ಕೆ small amount of CH3CONA ಅನ್ನು add ಮಾಡ್ತಿದ್ದೀರಾ. Due to the presence of this common ion, that is CH3CO minus, the equilibrium will be shifts to the left side. CH3COH will dissociate into CH3CO minus plus H plus, and this CH3CONA will dissociate into CH3CO minus plus Na plus. Thus the dissociation of CH3COH will get decreased or suppressed. Next one, hydrolysis of salts and pH of their solution. Salt hydrolysis, that is salt plus water, it will give acid plus base, because when you combine the acid and a base you will get the salt. So this salt, upon adding a water, you will get acid as well as a base. Hydrolysis is a process which is reverse of neutralization reaction. Hydrolysis of salts of strong acids and weak bases. Example, NH4Cl, NH4NO3, etc. When NH4NO3, upon adding a water, it will give NH4OH plus HNO3. NH4 plus, upon adding NO3 minus plus H2O, it will give NH4OH plus H plus NO3 minus, and NH4 plus, upon adding, it will give NH4OH plus H plus. So you can write, after hydrolysis solution will be acid. After hydrolysis, the solution will be acidic. pH is less than 7. Since only cations of the salt participated in the hydrolysis, here you can see this reaction. It is known as cationic hydrolysis. Hydrolysis of salts of strong base and weak acids. Salt base plus strong base plus weak acid reaction. CH3CONA plus H2O. It will give CH3COH plus NaOH. Or you can take CH3CO minus Na plus H2O. It will give CH3COH plus Na plus OH minus. After hydrolysis, the solution will be basic. The pH value is greater than 7. In this type of hydrolysis, only anions of salt take part in the hydrolysis. It is known as anionic hydrolysis. Next one is hydrolysis of weak acid and weak base. Weak acid ಮತ್ತೆ weak base ಅನ್ನು ಯೂಸ್ ಮಾಡಬೇಕು. Example, CH3CONH4 plus H2O. It will give CH3COH plus NH4OH. Or you can write CH3COH, upon dissociation it will produce a CH3CO minus. So CH3CO minus plus NH4 plus H2O, it will give CH3COH plus NH4OH. pH of the solution depends upon the relative strength of the acid and base. Next one is buffer solution. The solution which resists change in pH on dilution or with the addition of small amount of acid or alkali are called as a solution. So ಇದೇನು ಮಾಡಬೇಕು, solution which resists the change in a pH on dilution or addition of a small acid or alkali. ಒಂದು ಸೊಲ್ಯೂಷನ್ ಇದೆ, ಅದನ್ನು ಡೈಲ್ಯೂಟ್ ಮಾಡಿದವಾಗ ಅಥವಾ ನೀವು ಅಲ್ಕಲಿ ಅಂದರೆ ಬೇಸ್ ಅಥವಾ ಆ್ಯಸಿಡನ್ನು ಆ್ಯಡ್ ಮಾಡಿದವಾಗ ಪಿ ಎಚನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಇಡಬೇಕು. ಅದನ್ನು ನಾವು ಬಫರ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಕರಿತೇವೆ. CH3COH ಪ್ಲಸ್ CH3CONA, it will form H2CO3 plus HCl. These are the buffer solution combination. Acidic buffer, weak acid and its salts with a strong base are known as the acidic buffer. pH is less than 7. Example, CH3COH, CH3CONA, HCl, etc. Basic buffer, basic ಇರಬೇಕಂದ್ರೆ pH greater than 7 ಇರಬೇಕು. NH4Cl, NH4OH, etc. Next one, solubility product. It is applicable to sparingly soluble salt. There is equilibrium between ions and unionized solid substances. Consider an example, BaSO4, barium sulfate. Upon dilution it will give, or dissociation it will give Ba2 plus and SO4 2 minus. Apply the law of mass action, it will convert into K is equals to Ba2 plus into concentration of SO4 2 minus divided by concentration of BaSO4. So here KSP is nothing but solubility product is equals to, cross multiply these two, K into concentration of BaSO4 is equals to concentration of Ba2 plus into concentration of SO4 2 minus. KSP is called the solubility product constant or simply solubility product. Under equilibrium, KSP is equals to QSP. The solubility of salt of what weak acids like phosphates increases at lower pH. Next one is equilibrium. It can be established for both physical and chemical processes. At the state of equilibrium, the rate of forward reaction is equals to rate of backward reaction. You know it. Equilibrium constant Kc is expressed as the concentration of the products divided by the reactant, each term raised to their stoichiometric coefficient. Here is an example, AA plus BB will give CC plus DD. It is a equilibrium reaction, so it will give forward as well as a backward product. Applying the law of mass action, the equilibrium constant can be expressed as concentration of C to the power C, concentration of D to the power D divided by concentration of A to the power A, concentration of B to the power B. Next is Le-Chatelier principle. It states that change in any factors such as temperature, pressure, concentration, etc. will cause the equilibrium to shift in such a direction so as to reduce the effect of the change. Electrolytes, substances that conduct electricity in aqueous solution are electrolytes. Next important point from this topic is Arrhenius concept. According to Arrhenius, acid give hydrogenous while bases produces hydroxyl ions. Arrhenius ಪ್ರಕಾರ acid ಅಂದರೆ H plus ions ಅನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಬೇಕು, ಬೇಸ್ ಅಂದರೆ OH minus. Bronsted-Lowry concept ಪ್ರಕಾರ acid as a proton donor and base as a proton acceptor. Next ಬರುವಂಥದ್ದು conjugate base and conjugated acid concept. When a Bronsted-Lowry acid reacts with a base, it produces its conjugate base. ಆಸಿಡ್ ಬೇಸ್ ಒಟ್ಟಿಗೆ ರಿಯಾಕ್ಟ್ ಆದವಾಗ ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ಮತ್ತು ಕಾಂಜುಗೇಟ್ ಆಸಿಡನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತದೆ. Conjugate pair of acid and a base. Conjugate pair of acid and base differ only by one proton. ಸೊ ಒಂದು ಆ್ಯಸಿಡ್ ಇರ್ತದೆ, ಒಂದು ಪ್ರೋಟಾನನ್ನು ತಗೊಂಡು ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ಆಗ್ತದೆ, ಬೇಸ್ ಇರ್ತದೆ, ಒಂದು ಪ್ರೋಟಾನನ್ನು ಕೊಟ್ಟು ಕಾಂಜುಗೇಟ್ ಆ್ಯಸಿಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಒನ್ ಈಸ್ ಲಿವಿಸ್ ಆ್ಯಸಿಡ್ಸ್. Acid is an electron pair acceptor, base is an electron pair donor. ಲಿವಿಸ್ ಪ್ರಕಾರ ಆ್ಯಸಿಡ್ ಅನ್ನುವಂಥದ್ದು ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ ಅಸೆಪ್ಟರು ಮತ್ತು ಬೇಸ್ ಅನ್ನುವಂಥದ್ದು ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ ಡೋನರ್. ಪಿ ಎಚ್ ಸ್ಕೇಲ್ ಅಂದರೆ ಹೈಡ್ರೋನಿಯಂ ಅಯನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇನ್ molarity is more conveniently expressed on a logarithm scale. ಹೈಡ್ರೋಜನ್ ಅಯೋನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅನ್ನು ನಾವು ಲೊಗಾರಿಥಮ್ ಸ್ಕೇಲಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೇವೆ. ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಅ ಪಿ ಎಚ್ ಸ್ಕೇಲ್. ದ ಪಿ ಎಚ್ ಆಫ್ ಅ ಪ್ಯೂರ್ ವಾಟರ್ ಈಸ್ 7, ದಟ್ ಈಸ್ ನ್ಯೂಟ್ರಲ್. ನೆಕ್ಸ್ಟ್ ಬರುವಂಥದ್ದು ಬಫರ್ ಸೊಲ್ಯೂಷನ್. ಇಟ್ ಈಸ್ ದ ಸೊಲ್ಯೂಷನ್ ಹೂಸ್ ಪಿ ಎಚ್ ಡಸ್ ನಾಟ್ ಚೇಂಜ್ ಬೈ ಅಡಿಷನ್ ಆಫ್ ಅ ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್ ಆರ್ ಅ ಬೇಸ್. ಒಂದು ಈಗ ಸೊಲ್ಯೂಷನ್ ಇರ್ತದೆ, ಅದಕ್ಕೆ ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ಆ್ಯಸಿಡ್ ಅಥವಾ ಬೇಸನ್ನು ಹಾಕಿದವಾಗ ಅದರ ಪಿ ಎಚಲ್ಲಿ ಯಾವುದೇ ವೇರಿಯೇಷನ್ಸ್ ಇರಬಾರ್ದು, ಅಂಥದ್ದನ್ನು ಬಫರ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಕರೀತಾರೆ. ಎಕ್ಸಾಂಪಲ್ CH3COH plus CH3CONA. Next, solubility product. For a sparingly soluble salt, it is defined as the product of molar concentration of the ions raised to the power equal to the number of times each ions occurs in the equation of the solubility. Actually AgCl ಮತ್ತು Ag plus ACl ಬರೆದರೆ ಲಾ ಆಫ್ ಮಾಸ್ ಸೆಕ್ಷನನ್ನು ಅಪ್ಲೈ ಮಾಡಿದರೆ K is equals to Ag plus into Cl minus divided by concentration of AgCl ಅಂತ ಬರಿತೇವೆ. ನೆಕ್ಸ್ಟ್ solubility product KSP is equals to product of this constant into concentration of AgCl, that is equals to Ag into Cl minus. So this is a solubility product equation. So this completes chemical equilibrium. Thank you.